Okay, thank you for everybody who's spoken before this. This is now the last chapter of our seminar, and I'm going to introduce a teammate of mine, Josefina Pallas. I hired Josefina when I was looking for somebody who had a European understanding of carbon and also a interest in the BIM tool building work that we're doing, and she's been steady on that and now has actually moved forward in her own profession in Europe, in Finland, with carbon data. So she's going to be speaking today about the work we've been doing within the automated wood manufacturing industry, the panelization sector, specifically on walls. And we have translated the presentation to French, but she's going to be giving this in English. So thank you, Josefina, and I turn this over to you.
Thank you, Eli. Okay, let's start. So, as Eli mentioned and introduced me, we have been working together on carbon footprint evaluations for different topics, but this project that I'm going to present now is specifically for the panelization sector and specifically on walls. So this is called like a benchmark study, let's call it like that, and it's a pre-EPD because we didn't actually created an EPD, we just did all the studies before that. I will explain in the next slides why we didn't achieve the EPD yet. So as mentioned before, the fabrication of walls and also trusses in Quebec, they use most of their wood from regional mills. So they have a lot of like wood consumption, which will impact at the end the EPD of these products, so the carbon footprint. The EPDs are something complex of creating, at least the first ones. So the first EPD for a wall, let's say, can take up to 1 year. That is like the statistics for a normal EPD creation. This could be because of the gathering of data, which we'll see in the next slides, how complex or how diverse it is. Hopefully this year in 2025, the impact of certain initiatives and EPDs for Canadian wood will change the scene for this, and we will see like an increase on the use of these walls and the market in Canada. That could lead also to the increase of needs of EPDs in more specific products like trusses and walls. If we dive more into detail on why we have, or what is like the context of this benchmark that we did, is that there is different types of EPDs, as I have assumed you just now learned, but you could do for a shop that fabricates walls. Let's use now the example of walls from now onwards. So for a shop that fabricates walls, you could have an EPD of the shop itself, or you can have an EPD of the product, the wall. ISO standards mention that if you have a variation of more than 10% on your products, you will have to create an EPD for each product, and you cannot do like a standard EPD for all. So that is what we are trying to explain here. And because walls usually have different specifications or have different variations on their functions, how we say here that the wall number 1 is mainly the structure, but then we have the layers related to energy, the fire resistant, and the acoustic. All of these are like extra layers added to the wall, so extra materials added. And in this case, we believe that it will be difficult to keep the variance less than 10%, and because of that, we would need a product-specific EPD. For our first part of this study, we started with the structure. So the wall number 1, which is the simplest one, is the one that is just wood and nails. So 2 main materials for that. If I go a little bit more deep on the explanation on the different type of EPDs and why it is relevant in this case, in the case of the first one, the third-party EPD, it's the most common EPD we can have. It says that it's for all applications, and in the description, you can see in the slide that it says parent EPD, because if you have this parent EPD to be of a product that then you will have the sister EPD, so the one below, which is the same product with a little variance on the carbon footprint, then for a shop, like a shop, let's say, that fabricates walls, it would be a tremendous benefit for them if they could have one parent EPD for one wall and then just have sister EPDs for the wall with different variances. This would be like the ideal scenario. Well, in this benchmarking, we are studying if that would be actually possible, because if the variance in the walls is too much, then you cannot do that. And then you would need to do like an individual EPD for each wall, which implies a lot more work and time, of course. Then there's also the design phase EPD. So this is an EPD when you're releasing like a new product. So that's why it's 8-month validity, because it's like when you want to launch a new product to the market. And then you have the project EPD, which is for cases like ours that we are doing benchmarking and testing, or for specific building projects also. So now we're going to get into the actual study. We used just as reference this shop. The selection of this shop was also because they have one specific line that focuses on walls. So we could analyze the impacts of the shop and kind of discriminating this line that focuses on walls, because we are focusing on walls. They also have a very good organization of the shop, which allowed us to study it very well in the terms of transport within the shop, that we will say now why is that important, and also waste management of everything that is involved in the creation of the walls. You will see here, these are pictures of the shop that I think they help. We wanted to show them because they help show you better everything that is involved in the creation of an EPD. So in analyzing the impacts of this shop and the fabrication of the walls. So here you will see that, well, you have like the materials stored, and then you have the waste management place, then you have the transport within the shop. All of these things, they need to be taken into account when you create an EPD. So for example, that little transport that you use to grab the stored material and then taking it into inside the shop and turning it into a wall, that carbon footprint needs to be added too. Those are things we learned on the way, which were very new to us. And I think most of people, mostly shop owners, maybe they don't see this also as an impact. I think the most commonly impact people usually have in their minds is like just the materials you use to make the wall, but it's not just that. And it's not only just the energy your shop use, it's all of the things involved in the process since you got the material into the shop until you get it out in the form of a wall. This is, for example, another topic that I think is new to people that want to make an EPD, and it's the fact of the transport. So it's not only the transport when the wall is done, it's also the transport within, it's the packaging that you use when the wall is done. Well, the transport used to move the finalized wall from inside the shop to the transportation that will take it out of the shop. Another important aspect of this under of an EPD is the waste management. In this case, this shop was a great example because they had a great system to manage the waste. So some of it is used for heating of the same shop. Some of it is reused in some other way. All of this has to be added to the impact of the wall itself. So it's great if you are able to reuse your waste, and then if you're not able to reuse it, then the way you handle that waste, for example, burning, that has also an impact, a carbon footprint impact that you will need to add. These are our preliminary results on the, let's call it pre-EPD, that we have done on walls, and I'm going to explain each chart separately. So here in the first one, you have global warming resource types. So a resource, as you can see here, is not only the materials used, as we mentioned before, is the energy you used, either for transport, but also for manufacturing. So in this case, because we are using Tracy, the transport is included in the materials. But here you will see that, for example, what has the biggest impact in the carbon footprint is the OSB. Then it comes the softwood. And then we have the energy supply for heat, so heat from wood-based fuels, and then energy supply heat from fuel oil. And well, you can see that the energy used has big impacts. And then the manufacturing basic metals is actually the manufacturing of the nails we used in the wall. It sounds very like foreign or distant to the wall fabrication itself, but it's actually something that you need to have included in the analysis. And then electricity and, well, other tiny things. Here is a chart on the classifications. So you have to classify like your materials when you do the analysis, and the sheathing, which is made of OSB, has the highest impact. Second is the lumber, and then is the rest, which is nails, because we don't have any other material. It's just lumber, framing nails for the lumber, and then sheathing made of OSB, and then the sheathing nails. And this chart shows the global warming per life cycle stage. So the one that has the biggest impact is the raw material extraction and processing, then the transport to the manufacturer, and second is the manufacturing, and third, the transport to the manufacturer. So this shows that actually the materials itself has the highest impact rather than the process, the manufacturing process and the transport. In other cases, it could be in another way. I would like to say that we are still analyzing and working on this, but something else that was not shown, and I'm realizing now, is that in other classifications, these are the nails actually, and here you can see that the nails have kind of the same impact. I mean, not the same, the lumber has less impact than the nails. So in this case, we are saying that we are seeing that the OSB has the highest impact, followed by the nails, and then the lumber, which also was a great finding for us because the lumber has the lowest impact. Now, yes, back to the findings and the summary of this work. I would say that, well, the context, I think I have already went through it, but these shops consume a lot of wood from the region. So if we improved the EPD and the quality of those woods, we would also increase the quality and the carbon footprint of the products that will be using those woods. EPDs are difficult because they need a high diversity of sources and data points, as you have seen. It's not only the materials, but it's everything related to the shop. We are seeing that if we don't manage to get a less than 10% variant on these products, we will need to do an individual product EPD for each, which will imply more work. And ideally, we would like to have sister EPDs. So we would like to have products that have similar impact so we could accelerate and make the EPD creation more efficient. And some preliminary conclusions that we have. Yeah, I think the first one is not a conclusion, but it's just like a statement that for the report and for this analysis that you have just seen, we have been using a Nordic software that focuses on making LCA and EPDs analysis. I think the use of a software like this has allowed us to do a lot of benchmarking, which in simple terms and in practical terms means that we can select one material and at the same time select two different materials from maybe a different region. And in that moment, like instantly, we can see the results and compare the different type of carbon footprint that different materials have. Not only materials, we did a pretty good benchmark study on also the manufacturing energy used. So the different type of energy sources and how those impact the carbon footprint of the whole product, as well as with transport. So I think it has a benefit in the way that it allows you to play with different sources and options. And that's the whole, I think, idea of a benchmark study. The reports, once you have all the, as we said, all the most difficult part is adding the data there, so the data points and the information and the quantity. But once you have all of that, it's quite easy to change and create the reports and have a result. Materials that are not model and seen, but have a high impact, but like nails, also are very relevant in this study. And I think it will become even more relevant as we continue with this work.
Thank you, Josefina. That was an excellent description of our point in time as we work along on this process. And thank you for all your help on this. It's great that you have been able to learn so much about the wood industry while bringing your knowledge on carbon data. So I'm going to wrap up. We've seen two separate study points going now where we have the majority of the impacts are coming from the products that are being bought by the Quebec shops. So I think that's a really good highlight. Between 75 and 78% here of the impacts are really not controllable by the value add manufacturer. So what that means is we're using the data of what they purchase, and we cannot ask our wall manufacturers to be product research experts. We are telling them what we want them to build. The market is telling them, or policy is telling them. So I think it's really exciting now if policy in Canada were to say, we want you to build more Canadian, more biosourced, more materials from close by. That's going to be a very different, it's going to have a big change in the impact. And we also believe that the studies done by Forac and Agico in the coming year that are going to show specific data on lumber traceability are also going to show that Quebec sawmills are very efficient and we may be better than the North American average. So in some ways, it's premature to do the EPDs right now because they're about to get, we hope, a lot better through your help. So we want to basically cheer on this project and hope that you go out there and get a lot of data to show that the Quebec manufacturers are among the best. And then we're going to be ready to update the carbon benchmarking and then pull them forward into verified EPDs. And we also hope that anybody on the policy side who's watching this can realize what a big impact that housing policy or carbon data policy or Buy Canadian policy can all have on this sector. So thank you for everybody for joining us today, and we expect that we'll be showing this video in a panel session where we can also answer some questions personally. But until then, QWeb USA is glad to be helping out QWeb in Quebec and Group Agico and our funding partners to help get really good data about Canadian manufacturers. So with that, I conclude our seminar of the day. Thank you.